Hello everyone. So today we're going to talk about so what I've noticed a lot of students in vibration is what happens is when they encounter problems that require them to find the basically to find the center of gravity and the moment of inertia or moment of inertia, and using the parallel axis theorem, how to use the parallel axis theorem. So they go through a lot of trouble, and I thought I'd make a video on how to actually go through easily through these, and just walk you through it step by step and get you up to par so that you don't have to basically stumble upon it every time you do a vibrations problem or physics problem. So let's get down to it really quick. So first things first, let's get an example up here, and we'll go through it together, and maybe that will probably help a lot. So okay, so you'll find this probably a lot in the examples where you have a pendulum. So let's talk about a simple pendulum first. So you've got a simple pendulum. The funny thing here is that you've got the bob, which has a mass m, right? And then the only issue here is you don't really have a radius. The bob is like too small, so the radius is ignored. So that's the simple pendulum. So but then you've got this length here. That's the length of the pendulum. You've got length L. So for this simple case, really, you don't have a shape. You don't have anything. So you're going to do the simple mass times the length squared, because that's what the parallel axis theorem says. You've got the shape, and so the center of gravity is considered to be right here, because the rod or the pendulum is assumed to be a simple one, and it's of negligible mass, right? Negligible mass. So has no mass, so you can't really, so the center of gravity is right here. That's your center of gravity. So what the parallel axis theorem says is you add the moment of inertia of the object or the shape that you have plus the moment of inertia, the mass times the distance from, so let's say this is, so you have to select an axis first, right? So that's your axis. So the distance from the shape to the the distance from the center of gravity of the shape to the axis. And we'll expand more on that in a few seconds. But if you know what that means, the d here is basically L squared. In this simple case scenario, the moment of inertia for the object or the shape is basically zero. So because you don't really have a shape, or you don't have a defined shape of some sort, so that's what you do. So simply, it comes down to IML squared. Okay, so let's say you have a pendulum. It's still considered to be a pendulum. It's a pendulum, but it's got this physical appearance. So the rod is basically thicker, and you've got some mass, right? Actually, let's start off with having just a shape and a small bob. So we're still with the radius ignoring the radius, right? So the radius is ignored, but we have a shape now. So this is a mass. It's got a mass m, right? and let's call this M1, this is M2. So we have a mass. So what we're going to do here is basically, so we're going to do this. So so how many objects do you basically have? So you've got this shape here. So that's your rod, plus the parallel axis theorem for the rod. So the center of gravity. So we're going to consider this to be uniform, right? So uniform rod. And then M1, right? And so what is this distance D? That's distance D. It starts from, so okay, let's actually just, let's just agree on something. So first things first, you have to define your axis, the axis that you want to find all your moments about. So in this case here, it's going to be this. It's going to be the end of the pendulum here, or the end of the rod, the line passing through the axis of rotation. Okay, your axis can be defined. You can actually define it wherever you want, but in this case, we're going to set it right here. Okay. Let's go back to that color of ours. Okay, so that's your M1, and that's going to be, let's say this is going to be, so the center, from the center of gravity of the shape, which is the rod right now, the uniform rod, to the axis. So we're going to call that D1. So D1 squared. Okay, now let's do the other shape. This shape here. So this shape here really does not have a shape. So let's say eyebalb, okay? We're going to consider this to be 0, but let's just put it there for a second, and then we'll simplify it later. So then plus the parallel axis theorem, so that's M2 times, so the length here, which is right here, that's going to be your L. That's going to be L squared, okay? So if we simplify that, then this is going to be I112 times M1 times L1 squared M1 plus U1 squared plus, this is going to be 0, right? This will be 0 plus M2 L2 squared. That's it. You can also simplify this down to become 1 over 3 M1 L squared plus M2 L2 squared. L squared, sorry. Yeah. So, okay, so that brings us to the next thing. So, when you have a rod, if your axis, if you take the moment about this right here, this axis, if this is your axis of rotate, if this is your axis, then what you're going to do is, this is your I, that's your moment of inertia, M, so it's the mass M, length L squared. However, if you take the mass, if you take the moment of inertia about this point, that's going to be 1 over 3 M L squared. So that's something you have to keep in mind, right? Okay. Okay, so let's move on to the third system, which is when you have the pendulum with a rod, and you've actually got a bob with a radius R. So in this case here, what you do is, so you do your I shape, which is your shape, which is a rod, and then your parallel axis theorem, so that's the center of gravity. That's your D1, so That's your M1. Sure, M1, M2, D1. Oh dear. D1 squared plus. Now you've got a shape. So that brings us to the good, nice. Okay, so for a shape, for a disk shape, you're with a radius r, flat disk, right? Flat disk. This baby here is basically half m r squared. That's your I. So we're going to do that because we've got a shape. Oh, before we do that, sorry. We're going to simplify that later. We're just going to put I disk and then plus. Now we're going to use a parallel axis theorem. So that's going to be length r, right? So r, L1, L, L. So it's going to be M2 R plus L, right? So we simplify that. 1 over 12 M1 L squared plus M1 D1 squared plus half MR squared plus M2 R plus L. So there you have it. I hope that helps. This is really important. I figured this is where students mess up a lot, and it take time to like grasp and catch stuff. And I'll have another video that actually talks about how to find the center of gravity. So let's suppose they give you like a different sort of shape with a pendulum of this sort, and you don't know where the center of gravity. So I'll teach you how to find the center of gravity in that case, and we'll do an example. Actually, you know what? We'll do an example, and until then, I'll talk to you later. Bye bye.